This screencast is used in conjunction with Chapter 9 in AP Chemistry, and it's going to focus on what entropy means and some applications of entropy as far as other molecules. So if you've been following along on all the other screencasts, some of these things are going to be repetitive, and you've already heard these. Remember, entropy is talking about the amount of disorder or the disorganization, and solids are least disordered, so you'll have a smaller entropy value for solids, and it will increase through liquids and gas. Gases have the most disorder. They float around. They're the least organized in their molecular structure. The number of moles that you have of a substance will increase the entropy. So just like if you have more people in a room, you're going to have more disorganization. If you have more moles of a substance in a reaction, you're going to have higher entropy. And also we've talked about that if you have more mass in a molecule or in a compound, you're going to see a higher entropy value or more disorder because there's more particles involved. So if you look at a molecular level, and we have this reaction here, 2NO plus O2 makes 2NO2. If you look at it from left to right, you see on the left side you have, we can see that we have 3 molecules, 2 NOs and 1 O2. And on the right side we have 2 NO2s. So if you think about it, we're going from 3 molecules or 3 moles of a substance into 2 moles. So this is not creating more disorder, so therefore this reaction would be not spontaneous, and it would have a negative entropy value. The products have less moles and they're tying up more atoms, meaning we've organized this better. So this is not a reaction that's going to go on its own unless we put heat into it or energy, and the entropy is going to be is negative. The next bullet point says reducing the degrees of freedom, meaning more freedom and more entropy. So if you have more freedom or more molecules able to move about, you're going to have a higher entropy value. So you're going to be able to look at reactions like this and analyze in your brain, okay, well, how many molecules are there, or how many moles, how many particles do I have floating around, and you're going to need to be able to rationalize whether something is spontaneous or not, meaning it doesn't have a positive S or a negative S value. All right, so there are 3 different ways that molecules can be moving, if you will, or the 3 modes of freedom. The first is translational, the second is vibrational, and the third is rotational. So you got to think in terms of a molecule. If a molecule is translating, it's physically moving from one point to another in space. So it is moving around. It is going from here to there. That's translating. In vibrational motion, that is the bond is lengthening and shortening. So it is just it's just zipping back and forth. Okay? And then rotating is where it's spinning around an axis. So there's my version of a spinning around an axis. Energy is required for all 3 of these, and the more energy that you have in them, the more movement you're going to see, and that makes sense. The more energy, the more heat you have, the more the molecules move around. But even in a frozen molecule, in a solid, you're going to still have vibrational motion. You might not have translational motion, you might not have as much rotating going on, but it is still vibrating. The bonds are still vibrating within the solid. So the more energy you have, the more entropy. Think of a 3-year-old on a sugar high. If you give, a little child too much sugar, they are going to be bouncing around the room and have more energy and therefore cause more disorder. And as we increase the temperature, we also tend to see more entropy. So all of these make sense. These are just connecting to processes you've seen before and explaining maybe further in depth. But you're going to be able to look at reactions and interpret these different factors like energy or temperature or the number of molecules that are tied up and how they're going to change the situation.